Alright, so this is problem number 69. You can see there's a decent amount of algebra, and there's even this part over here which says lots of algebra later. It would just be too messy if I showed how to do all of it, but it's not inherently difficult. You just gotta keep everything straight. So this is the tennis ball and the basketball system. T for tennis, TO is the initial, and just T is the final. There it is. Oh, over here I did final, but then I switched it to, if it doesn't have an F, it's final. And if it has a 0, then it's always initial. Right? This is kind of the key to everything. The velocity, the initial velocity of the tennis ball is negative v. The initial velocity of the basketball is positive v. You can use per part A this kinematics equation to get the velocity, and this v is consistent throughout the problem. It's just that, initial velocity. We use conservation of momentum in part 2, along with these things, which are mostly the key to the problem. Just got to keep everything straight here, and we plug in, equation 1, we plug those values into here, and we get this. Basically just factor it out of v, since both of these kind of reduce to v. This is another important thing. This is the collisions thing, equation. You've seen this several times already, and you just have to keep everything straight until you get to here. Yeah? So you've got a second equation after plugging in 1 into here. This is kind of the first equation we're going to use, and this is the second equation over here we're going to use. We plug in 3 into 2 to solve for the velocity of the tennis ball. And I said lots of algebra. Maybe that's a slight over-exaggeration, but to get it this clean, yeah, it would be a decent amount of algebra. I would say I would leave v as the square root of 2gh, just because when you have to apply it over here, it's going to get squared, and why not square that to just get 2gh out, right? But that's just, if you get all of this and then you have trouble plugging in, you're not going to mark down so much, but your answer should be here. The key to this problem was being able to see this with the tennis ball and the basketball, and applying this for collisions. Everything else is kind of stuff that we've done before, and even this is stuff that we've seen several times already. If you got this right, if you got this opposite, you're in trouble. If you didn't get this at all, you're in trouble. But this is kind of the big key to the problem. Everything else we've kind of seen before, just that this is super important. And yeah, I guess you could use kinematics a couple times here, which is probably nice for you.